Hello to viewers, welcome to my channel Science to Technology. In today's show, Rocket Monday, we're going to talk about Spacex Starship Integrated Flight Test number 5. So let's dive deep into it. So this puppy happened on 2024 October 13th at 12 Universal Time Coordinate or 6 p.m. in India, and I did a live stream. It went quite well, and launch license was the very messy part. It was cleared literally hours before the launch, so to say, not even like weeks, hours. So that was a very close call, so to say. And takeoff was very smooth because be mindful, last takeoff we had some engine failures. Now be mindful, this system is multi-engine redundant, meaning multiple engines can go yeet and they can still survive, still actually go to orbit. So that's the good part. But again, you do not want that to happen. That's like worst case scenario. You do not want that to happen. Nothing like that happened. Now catch happened flawlessly. Now be mindful, catch is one of those structure which makes sense in physics level, makes sense in economics level, does not make sense in engineering level. But somehow they had this engineering done and they did it. First go. Like, this is significant. Remove everything. This is genuinely significant. Whereas like you're telling me that you're just gonna yeet a rocket out of mid-air, and that rocket is not a tiny rocket. This is not a net. This rocket is the size of skyscraper. And again, that's another problem. Like I do expect some, like they have to figure out a way to bring this next to some places where people can see. So it's like, oh, this is the size we are talking about. So you have to understand, like, this is huge. So it worked. And re-entry, while it did suffer heat shield failures, again, it did manage to land exactly, precisely where it's supposed to go. So hats off to the people who wrote their navigation software, because damn, even with failure, even with partially messed up airflow, it's like, I got you, fam. I'm gonna get you where you need to go. So it was a surprisingly good show, especially the catching part. Catching was like, are you serious? Like, you actually did it. So it's like, damn. So let's understand the development aspect of it. Now, IFT-5 was last hurrah of Raptor engine Mark II. I did thought they will upgrade to Mark III, given the fact that so much delay was happening, but apparently not. But I think they would have enough rocket engines to yeet. So they're like, okay, let's yeet it. So they would be upgraded to Raptor 3. What's the difference? Now, the difference is 7% lighter. Now, each engine being 7% lighter is a significant weight saving. Like, that is, if you are hearing people say, we're gonna make the dome that they need to eject right now integrated, where would they get the weight? Well, again, first they will engineer it better. Second, engines are lighter. So 33 engine, 7% lighter, that's a lot of ton. Not as in like hundreds of ton, but ton. And 21% more thrust. Now, thrust is one of those things that if you have X amount of propellant, let's say you have this much, and if you can burn it faster, you can, same amount of propellant, you can go further. Like, if you are like, okay, I'm burning it at 2G, you can go D. And let's say you are burning at 3G, you can go 2D. The faster you can burn, like the more oomph you can get out of it, the more distance you will cover given the same propellant mass. So that's why thrust is beneficial here. And another benefit is, in case of an engine failure, the effect on basically how hard every other engine has to work will be very negligible. It's like, oh, one engine sneezed, no problem, bro, we got this. And during return also, because now you have such a big throttle range, it's like, I got this. I can easily allow to land. So it has significant advantage, not only in terms of going up, also coming down. And it's a bit more efficient. The specific impulse is a bit more efficient. Now, be mindful, could there be Raptor 4? Likelihood of that is low, simply because you can figure things out. I'll talk more about it. But these are the big changes that's going to happen. Now, catching booster is a very big deal from economics point of view. That's why I said, like, physics and economics is sorted in that. So simply because reusability, you may think like, why can't they just like, drop it into the ocean and catch it exactly like how they are doing? While that, from a rocket's point of view, makes perfect sense, it will bankrupt you if you have to do it daily. Like, the sea-going asset, the asset that is designed to go to sea, is not cheap. Just on the paperwork itself, you're going to go bankrupt. And having a barge that can handle that kind of ship and then safely secure it, then safely bring it, yeah, that things start to pile up in cost. Now, that's not an issue, because when Falcon 9 was built, this was like a hypothetical idea. Now they are actually doing it. It's like, yeah, it's like the same thing. Like, first time you buy a printer, you do not pay, I do not want to pay for like, ink tank printer. I only prints once in a while. The moment you have to buy the first cartridge, you're like, okay, let's eat the printer, let's buy ink tank. Is the same thing. Running cost of these sort of infrastructure is so expensive, it's not worth it. Meaning, it's far better. Like, again, Falcon 9 was Mark 1 product. Mark 2 product, they're like, okay, how would we do better? Day one, make sure it returns exactly where it needs to return. That has significant, everything was designed around that. They do not have the option, like they did not give themselves a cheap out. And again, that's the only way they can make it long-term economically viable, going from cartridge to ink tank. And no landing gear needed. Again, that makes the booster lighter. That is a good thing. That gives them enough storage for enough propellant mass so they can do boost back burn. And no sea recovery. That's cheap. And transportation and handling cost, because handling is deal. How the heck you are handling it? You have a factory. Factory has stuff like cranes that are building it. Then you have a transporter. You transport it to the launch pad. Launch pad has a... Now here's deal. How you are catching it back? Done. There is nothing else. Like the structure you have is the structure you need. Done. Like the same launch clamp would be used, the same arms will be used, and the same truck that you have, that multi-vehicle truck. So no handling requirements. So from a long-term running cost point of view, this is like short uptake money. And that's why, like when you look into Neutron, they are not even trying to land on the sea. Anyone who deals with the sea vessels, they are like, you would think it's not that expensive. It is idiotically expensive. So it's one of those things, like if you are actually planning to do it daily, or like, lots of process, it's like cost piles up so much. It's like, you know what, it's worth it to just develop a better rocket that does not do that. And what about the ship part? That's the booster. Ship part, ship landed precisely on target. How do we know on target? Because you have to understand the distances has covered. 1% deviation, it would be hundreds of kilometers plus and minus. So given the fact there was a buoy there, and it actually came in the field of view, that means it was good enough. It was like, no, I said it here, it's freaking here. And be mindful, this happened while it had a, like, one malfunction on the, basically melt through, so to say. So it did. Now, heat tiling did not work as expected, nor the, what you call the blanket. Now, what are options there? Well, improve the heat shield, or most likely they will do is like change the canards back. Canard still was the old design. The new canard design is moved backwards. So it's a behind what you call shockwave, so to say. No, because again, your blunt body reentry gives you a lot of buffer zone. So you want to make sure your canard is not poking into it. Now, canards can easily handle it. It's the joint that cannot handle that complex gas flow. So making it behind it, basically, instead of like this, you are tucking it in. It's like, no. And the edges, that's very easy to handle. It's just this part, the shoulders. You do not want shoulder to go into the flames. So it's like, what if you tuck the shoulder? You can see that part has not been launched, but it's tucked in. So that's the geometry solution of it. Again, if that also does not work, yeah, then they need some serious rework, like not lightweight rework, like some serious rework. So that's the development part of it. Now let's understand some real world reality of it. It's a risky project, which is what we call high risk, high reward. If you're, oh, it's a sorted, it's gonna happen. No, there is no such guarantee like this. This is a risky game, fundamentally, because the system is not being built from a blueprint. There is no blueprint that China can hack and it's like, okay, China is making it. It's like, nobody can do that because they have no idea. That's why they look at the animations every time is changing. Look at the design. The physical prototype from Mark 1 to Mark 2 to Mark 3 to Mark 4, Mark 5. And the reason why I'm calling them marks is because they're fundamentally changing every time. The only thing that is fixed, I think, is diameter. Nothing more than that. So they are doing what we call active development from testing itself, where testing is creating the feedback loop. So all vectors, all specification are in flux. So nobody can steal the data because there is no data. And even SpaceX does not know how it will work. And that's why they did the testing of the integrated flight test 1, given the fact that the engines they have built, the Raptor engines, was not powerful enough to do actual orbital. That's why they said that if it cleared the pad, we will be good. So that was the whole point of it. They just wanted to test things out. Now, was that wise? In terms of development, yes. Because here's the deal. Once you develop this, you figure out what is garbage in this. Okay, then you make this. Then you're like, what is garbage in this? Then you make this. This is fundamental. This is like going from 1G, 2G to 3G. So this is one of those things that people were like, why can't we come to this? Well, you can, but it will take 25 years. And then you're like, oh, that's why ISRO is taking so long to develop one goddamn engine. And again, even at that point, it may not be this good. It at best will only reach here. So if you go through what we call a hardware-rich pipeline, hundreds of other little things become far more refined. For example, how would people handle this engine? How would people bolt this engine into a chassis? They will develop a new cradle system that allows them to do that. You would never think of that. If all you are focused on, I'm making a perfect engine blueprint, you would not think of it. If you're hardware-rich, how the heck we transport it? Okay, we have to do this. How do workers install it? It's a small thing, but again, all of these pile up, specifically if your aim is to make hundreds of ships. So going through this approach, while wasteful in one regard, it was priceless in another regard. It wasted a lot of material, but it gave a lot of experience that you cannot copy paste from anyone else. It's like, oh, Now we know how we ship engines. Now we know how to manage engines. Now we know what is the wiring issue, what are the trigger issues, what are the failure points, ignition systems. Hundreds of things would be sorted from Mark 1. And that's just use and throw. Mark 2 is like, okay, let's see how far we can push it. Now you see, oh, so much improvement happened. Then Mark 2 to Mark 3. Now here's the Mark 3. Is it final? No. I do expect it to go through some polish, but not major revisions. Why? Because here's the deal. You can thermodynamically calculate how much oomph you can get out of a given propellant. It's chemistry. So let's say it's here. Mark 1 was here. Mark 2 is here. Mark 3 is here. Now, can it touch it? No. Law of physics does not allow that. But again, you can get close. But here's the deal. Every jump from this point forward would be exponentially expensive and very minimal in return. Now, I could see them changing metallurgy to improve the resiliency and all that. Those sort of changes I can easily see. But in terms of like complete redesign, like how this is this to this, yeah, that's not that viable. So if now this creates another penalty. Why does not every company does that? If your R&D budget goes YOLO, like I'm pretty sure it went billions of dollars here, billions of dollars here, billions of dollars here, and again grand total, it could reach a point where the final product will not be valuable. It's like you have spent hundreds and hundreds and hundreds of millions of dollars to develop a thing that cannot be sold for that kind of cost. It's like I spent $75 billion to develop a cure for common cold. Yeah, nobody's gonna pay you for that. If it's like, okay, I spent $100 billion for AIDS, I'll be like, okay, shut up, take money. You see the priority. So you are spending so much money that there is a risk. And that's why companies that have built rocket, that have actually sent rocket from a jumbo jet, why the heck that company went bankrupt after building it? The R&D cost was that high. Even though they built a final product, it was like, we spent so much on it, the debt is too high. So there is a serious risk of it, like where you can like spend too much on it, too much hardware rich does have a penalty. So you cannot just go YOLO on it. And again, I'm a bit worried that heat shield did not perform as expected second time. Again, I did expect the heat shields to have issue. It's not that the blanket should also fail and the stool should have melt through. Melt through was like, whoa. And that happened live. So I was like, whoa. So that's there. And another aspect is loss of customer. Right now, there is a lot of private investment into this and NASA's Artemis investment today. Artemis will go away eventually. And the likelihood of NASA renewing the contract for another multi-billion-dollar project, let's just say likelihood is zero. So there is a risk. This is a high risk, high reward scenario. Anybody who tells you, no, it's a guaranteed, no. That's like law level, like no. That's why the designers like Mark 1, Mark 2, Mark 3. So let's understand the moon part of the things. For example, Artemis program is a mess. Fundamentally, it does not make sense. If you ever try to understand it, you will freak out. It's like you are telling me that US public got a notice that we're going to do Artemis. Okay, cool, awesome. How? Yeah, we have no idea. Who's going to build the engine? We have no idea. Who's going to build the lander? We have no actual plan about it. It's like nothing was done. Like compare this to Apollo. Apollo was like, NASA, you built. Okay, NASA is built. Okay, you put man into orbit. You put man into orbit. Done. What's next? You put man on the moon. You put man on the moon. Done. Everything clear cut. Artemis, there was no clear cut path. Artemis has changed so many times that people forgot that it was called constellation during Obama. Damn, I'm old. So that's the whole point. There is no path. There is no like, this is what we do, this is how we do it, and this is what will be the end result. So fundamentally, it's stuck. What it's stuck in, what we call catch-up paradox, meaning when this Artemis project was built, it was literally built on the products and hardware of 1980. It's 50 years older design, like basically 50-year-old philosophy is in the core of it. It's outdated before it even began. It's not gonna work. Again, economically, you can make anything work. It's just like you can still run a steam train. It's just not economical. It's just like, that's the whole point. You can run it. It's just not economical. The same thing here. It's fundamentally outdated, fundamentally messy. That's why like some randomly they put it like, let's just put a lunar gateway into this and then let's just remove it. That's why like people do not understand what the hell is happening with lunar gateways. Like it makes no sense. We had whole Saturn V. It got the job done. And again, there was a plan, like when NASA goes to Congress for, it's like, hey, we need money. They have to give some options. There was an option where it's like, okay, let's rebuild Saturn V with modern technology, as in like, rather than 60s technology, 90s technology. And it would have been a magnificent jump in terms of capability, performance, and they would have made sure it's cheaper. But yeah, they were like, okay, let's go to even cheaper route, that is like reusing shuttle parts. That's why Constellation was made. Shuttle was like, hey, we have to cancel shuttle because again, shuttle is like not good. It was a bad design craft. And yes, they did plan to make a shuttle 2.0, which should have removed a lot of safety concerns, but inherently, it was like inherently it had like escape to orbit as a overt mode. Like, think about it. It's like, are you going to abort to orbit? What if something bad happens before that? Yeah, bye bye. So fundamentally, you have to understand. Sometimes you can get stuck into what we call catch-up paradox. It's like, no, you design this part, design this philosophy, design this engine, design this whole mission architecture with what you had in 1980s. It's not gonna work in 2050. So what is known about it? Okay, so but why Artemis is going along if it's so messy? Well, it does have one clear-cut goal: thou shall beat China. So if tomorrow China is like, no, we're gonna land it, and it's damn sure that they're gonna do it, how Soviet Union freaked out America, that kind of way. It's like, no, this is gonna happen. I can guarantee you Artemis will get unlimited budget at that point in time. So that's there. Now, so fundamentally, understand scientific point of view. SLS is literally core of space shuttle, which first flew in 1981. So 1980, 1990, 2000, 2010, 2020. Yeah, it's ancient. So what about SpaceX? Now, SpaceX has even more stupid idea. Now, be mindful. Many times you're like, oh, SpaceX never have stupid ideas. No, many times they have stupid ideas. Elon Musk has a history of stupid ideas. It's just that most of stupid ideas dies and people forget about it. And again, for example, recently in Starship, you must have seen that flat plate. Everybody said it was stupid, including me. Every Tom, Dick, Henry was right that it was stupid. They're like, oh, but they made it work. No, they did not. They burnt money to make it work. And what they did in the next part, Mark II, they're like, okay, let's just put a curve there. Let's not fight the laws of physics. Let's not try to water cool that shit. It's like, let's just ease into it. So that's the whole point. Many times you can make a stupid thing work, does not make it logical. It's one of those things that like, there is a reason why every rocket launch is like, hey, let's just put curve there. Let's just accept it. Okay, let's just accept it. So it's one of those things. Elon Musk got a dumb idea where it's like, what if we take the second stage and yeet that to moon? It's like, why? And it's not even reusable in this design. It's not even reusable. Like, for example, let's assume Elon Musk claims that he can make stretched Starship Mark III with a Raptor 3 that can do 200 ton to low Earth orbit, which I doubt, but let's assume it can do that. Here's the deal. Done. That's a moon mission. How do we know? Saturn V was 150 ton to low Earth orbit, and we did the complete mission. And what was Saturn V? Saturn V was 2-stage to low Earth orbit. Like Saturn V is 3-stage. No. Saturn V is 2-stage. The third stage was the payload. The payload was like lunar injection rocket. So there was a rocket that's supposed to take from low Earth orbit to moon. So same thing they can do. It's like, hey, in one launch, they can like, okay, the second stage basically comes to Earth. The payload is like, okay, let me go from here to moon, do everything I do, come back, no problem, we good. And again, they could do even better. They do not even have to have a capsule for return. It's like, okay, come into low Earth orbit, dock to a Dragon capsule and use that for return. It would be far more efficient. So now the actual tonnage you have for lunar mission would be far higher in one launch. And again, let's assume, let's realistic here. He's only going to achieve, let's say, 100 ton to low Earth orbit. Do 2 launches. Payload, propulsion module. Done. Go. Sorted. But no, but what if we smoked weed, man? What if we put fuel into it? It's like you are putting hundreds of tons of fuel just to move few tons of people. It's like, why? It's a stupid idea. And yes, this is fundamentally stupid. How stupid? Let me be very clear. If they have to do 15, 16 or maybe 20 launches to refuel it, yeah, it's only be done 2 or 3 times. Because you have to understand the amount of LNG they are consuming. It's natural gas. The amount is bonkersly large. It's not going to pay a big issue if you're like doing it once a month. It's a huge issue for per mission if you have to do this 18 times. It's like, it's something that death by 1,000 cut kind of scenario. It will cause bankruptcy, assuming nothing bad happens during this. Assuming nothing bad happens, it's going to destroy your bank balance. So fundamentally, this whole idea of like, let's just yeet like, second stage to moon. Why? Put a third stage. We know this. And again, it's not even Mars where you need the aerodynamics. We learned this. It's like, this is what we call, like this same Artemis stupidity is this. Now, I know for a fact that this will be done. And then they will learn the hard way. And then they're like, yeah, we burned billions of dollars on this. Let's just eat this, then put third stage. So that's going to happen. That's bankruptcy fuel, but they're going to do it. So, and Artemis, what about Artemis future? Artemis will be cancelled because Inspector General Office has clarified that by the time government will actually get the bill for manned missions, they have to cancel it. One way or the another, they will be like, yeah, unless China spooks them, they have to cancel it because the target was $500 million per launch. Actual target was even lower than that, but 500 million. People are like, ah, cool, who cares? It's like moon, 500. It's 2 billion minimum right now. It is unsustainable. And it's so bad that they are like, Boeing forgot how to do welding. Not even joking, that is in the administration report from Inspector General Office. Not me saying it. That's like Are you serious? That actually happened on SLS. SLS the basically Mark II variant of SLS is stuck. So that will be cancelled. Let that be very clear. Sooner or later, it has to be cancelled. So there, without a major rework, where it's like, okay, let's throw everything away. Let's start with brand new, where you cannot have SLS. SLS is just too goddamn expensive, too goddamn slow, too much bankruptcy fuel. This cannot happen. Like maybe 1 to 2 launches, and then you're like, wait a minute, it takes how much money just on LNG? And again, LNG had to be bought from OPEC. And I was like, oh, what if they made it on site? It's like, oh yeah, energy, law of energy is like disappears. It's like thermodynamics, man. You have to spend that amount of electrical energy. It will be like data centers. America is suffering from data center fever that people are having because of AI. This will consume more than that. So fundamentally, there is an upper limit how much stupidity you can tolerate. One time, flat launch pad. Yeah, then it's like, okay, let's go with logical fem trench. So it's one of those things. I do expect this to happen 1 or 2 times, but I hope, I pray that somebody bitch slaps them, especially NASA. How the heck you smoked this? But again, so at this point in time, Artemis cannot sustain moon mission. It's just flat out uneconomical. It just cannot be done. Even there's a very good chance, even if China try to do it, they may not have that scare factor that he used to. So that's there. So there is only 2 probability. Either China bitch slaps America or Blue Origin does. Now, why Blue Origin? Well, Blue Origin is run by a dude known as the bald dude known as the Jeff Bezos. And the Bezos has money, like bonkersly large amount of money and stable money. His money does not fluctuate. It does not jiggle. It's like, bro, I'm solid. I'm loaded. I'm so loaded that after divorce, I'm loaded. Like, do not even come close to me, bro, I'm loaded. So that kind of man is scary. And he has a plan. And his plan has 3rd stage. So it's very logical. And they're not planning for like hundreds of launches. They're like, hey, it's a simple rocket. We can afford a boat. Because again, we only have to do it 1 time. And again, he already knows the paperwork because yachts, multiple of them. So he good, he sorted. So that's there. So Blue Origin could be slap it slowly, not right now, slowly. China could be slap it, that's there. And mathematically speaking, 2030 is the best scenario of manned landing on moon. That's the best we can do. So what about Mars? Now, again, no one is paying for Mars mission. Let's come to real world. No one is paying. And another aspect is many times children kind of get flocked into the, oh, billionaires. Billionaires does not mean you have billionaires. Billionaires simply means you have assets worth of billionaires. You cannot just sell it to anyone. Jeff Bezos is not going to sell, okay, I'm going to sell Amazon Web Services to who the hell is going to buy it? So you see, there is a limit to how much money he has. And even the yachts, that multi-billion-dollar yachts, it goes through so much paperwork, you will be shocked. Like, and there is an upper limit to how much personal finance you can just eat before, like, you know, your board of directors starts firing missiles at you. So there is an upper limit. And you have to take almost all, like top 500 to 600 people, all of their majority wealth, not like, you know, a small portion. No, majority, all of them wealth. Only then you have some chance of even trying to afford a Mars mission. Elon Musk is not that rich. Even Jeff Bezos is not that rich. So fundamentally, nobody has that much money to burn. Governments do that, but again, that's only for moon. We're supposed to have exponentially more advanced technology like 30 years from now, then we have some probability of doing it. Right now, it's flat not unaffordable. The best design I've seen was the movie Martian. It's like you build something in space that's designed for space, from space to space. It's like, I'm in space, I go to Mars, I come back. I never land on Earth, I never land on basically Mars. I just am a carrier vessel designed by space constraint, meaning there is no constraint. But again, you have constraint on mass, not on size. And again, you design it either with nuclear or you design it with solar. We cannot do that right now. We are not there yet. So there is no design where it's like, oh no, what if we sent this? It's like, yeah, remember, I'm old enough where this happened and I was like excited. I feel stupid, but I was excited. Oh, SpaceX is going to land. This was a hype. This was a zeitgeist at that time. This is April 27, 2016. Yeah, I'm old enough when this happened. It's like, you know, SpaceX plans to start sending Red Dragon capsule to Mars by early 2020. Yeah, that was bullshit. It's still bullshit. It's the same thing. Like how this looks stupid to you, this exact same thing looks when he shows like Starship doing that. Starship is not built for that. Starship is a vehicle to low Earth orbit. Anything from other than that, it's just like forcing a flamethrower to light a cigarette. It's wasteful. So that's the fundamental point. We do not have the technology. We need to have full-fledged moon bases, full-fledged space construction where we can construct things, hundreds of tons of construction. Then we can build something that can actually do like a Hermes, how you have seen in that. And again, we haven't even figured out spin habitats yet. There is no spin habitat in space where we know, okay, we can put people in space for 2 to 3 years without giving them kidney stones. So And again, you need like a decade kind of experience in space, not like, oh, he has like a space expert. And be mindful, right now without gravity they're not lasting that long. The health effect is brutal. That's why we need spin habitat. We haven't sorted that. So, oh, next 2 years we're gonna do Mars launch. No, you can do it. Let that be very clear. You can sign death warrant to someone, but it's unrecommended. So technology is not there. We need spin habitat. We need way too much things to be sorted before we can actually attempt it where it's sustainable. Unsustainable way, you can do it right now. You could have done that by Saturn V era. So that's there. There was an upgrade plan to Saturn V, whereas like, they had a Nerva engine, which was a nuclear hydrogen engine to actually go to Mars. So NASA cannot afford any mission. Here's the moon mission is unaffordable right now. It will be cut. It's just like as long as China is a threat, they're like, let's just bear the pain. The moment that China's pain goes away, like same happened with Soviet Union, it's just like, cut, it will happen. And public is not rich enough. You have to understand what was the era of moon landing. It was just after World War. There was a bit of fear, but there was bonkers amount of prosperity. You would not believe how much prosperity happened to America just after that. It's like you went like barely doing anything to like printing money, baby, and serious money, not inflation money, serious money. So they were rich. So it was affordable. Right now, students are, what is their primary concern? Yeah, I'm going to starve to death. What is the people's primary? Yeah, I'm going to starve to death. Everybody is like starving to death. Why? Because this happened. Inflation went bonkersly high too quickly. For example, inflation from 1910, they are keeping surprisingly good record, to like 1970, not that bad, not that bad. Like price hikes is like around 2x. From 1970 to 2025, it's like, it's like it stops at 2024, but it's like multiple x happening yearly. This is cumulative damage is too much. Like again, this is worldwide, by the way. Like I went from having paneer, like a cottage cheese, which was cheap. It's unaffordable right now. So fundamentally, people are not rich enough where you can just like, okay, we are burning billions of dollars. Like people were almost at the edge of burning NASA because of James Webb Space Telescope. Artemis, because money is going to Boeing, people are really not happy with it. So there. Another aspect is population. Population has already collapsed now because again, people do not study mathematics. They do not understand sometimes things happen in future. For example, when China applied one-child policy, everybody knew they're gonna be dead. But again, because it takes future, as in like I planted poison today, it will not give me fruits tomorrow. You have to wait for tomorrow. So same thing happens with China. China did that one-child policy, then they died, and it's like, oh, everything is fine. No, it's not. How do I know? Very good question. Ask China what is their current child policy. 3-child policy. Check it, double check it, I dare you. So that's the whole point. It's very easy. It sounds like whole planet believed in a lie. We are paying the price of it. And as of now, this is from 2021. Yeah, every place that is red, they did, and that translates to majority of the planet. Only Africa and little bit of Middle East. And yes, India also have dropped by 2024. India has also dropped below 2.1. Below 2.1 is like exactly how Corona went from doubling to bonkers large amount of Corona. Same thing is here. It's like nobody cares, boom, everybody's dead. And the timeline is 90 years. So China already reached it. Japan is hyper reaching it. And South Korea is like, I'm going to exceed all of you. And by the time people actually notice that, oh, this has penalty, they will be dead. So that's why this idea of Mars, economically speaking, physics, engineering, economics. Engineering, we are not ready. Physics is like, we good. Economics is like, but I don't even dream about. Like Mars, moon, maybe if you're lucky, by 2040. We have a proper base. It's actually working. But other than that, Mars is like very, like things have to fix themselves. Like this line has to stop. Line cannot go up like this. We're going to starve to death. Like literally, not even joking. Like, and again, God help you if you fall ill and you have to deal with medical bills. So that's the reality of Mars. So this was my presentation on basically SpaceX and their future. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst a friend. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free. And as always, thanks for watching.